Hello, this is Britt Kezel with a video on transformations. In this video, we're going to cover 4 basic types of transformations. The first one that we're going to cover is this one right here. This function is going to be talking about a horizontal translation. Okay, a translation meaning that it's a slide, so you're not changing or stretching the graph in any way. You're just sliding it either left or right. Now, an important thing to recognize here is that the h value, the number that's being added or subtracted, is within the grouping symbols. So if it's a square function, or a quadratic as we call it, you might have something like this, like x minus 3 in here. So because that minus 3 is inside the grouping symbols, that's how you know that it'll be a horizontal translation. Also recognize that this feels a little bit backwards. So if it says plus h, it's going to be taking you to the left. And if it says minus h, it's going to be taking you to the right. Now, if we add or subtract a value outside of the grouping symbol, then we have a vertical translation. Again, it's not flipping it or stretching it or anything. This is just scooting it up or down. So an example of this might be something like y equals x cubed plus 7. This would be moving it up by 7. Notice that the 7's not inside the grouping symbol of that cube. So if it says plus a number, you're going to be going up, and if it says minus a number, you're going to be going down. Now the next 2 transformations, these ones tend to change the general shape of the graph. This one here, where you're multiplying by a value of a, this is called a vertical stretch, or it could be a vertical compression. I like to tell my kids to think about if our graph was made out of silly putty, and you're holding it on the top and holding it on the bottom, and you're either squishing it down or stretching it out. Okay. Now the way that you tell is by the value of a. So if a is a number that's bigger than 1, you're going to have that vertical stretch. If a is between 0 and 1, so it's a fraction like 1/2 or 1/3, you're going to have a compression. But what if a is negative? Well, that falls over here in this one. So if a is a negative value, then it's also going to take into account some kind of reflection. Okay, a vertical reflection even. So this means that it flips the graph upside down. So a lot of times you might have something like a -2 out in front of the expression like this. The negative applies to the reflection, and the 2 applies to the stretch or compression. So let's go ahead and let's take a look at a couple of examples. Okay, so first we're going to start with horizontal translations. So this one is a quadratic, so it would graph like a parabola. This is my parent function. But this -1 tells me that I'm going to be going to the right by 1. So we would take all of our anchor points and scoot them 1 to the right. Alrighty, and then you can draw your parabola like that. Alrighty, now this one, this is a square root function, which looks like this. It has a +1 inside the grouping symbol. So this is telling me I'm going to be going to the left by 1. So we will take all of our little anchor points and scoot them left by 1, and then draw your graph. Our next transformation is a vertical translation. Okay, that's scooting things up or down. So here I have the absolute value of x plus 3. So this is saying that I'm going to move everything up by 3. So you can take these these anchor points and just scoot everything up three steps. And you should get something that looks roughly like this. Notice that the 3 is outside the grouping symbol. Okay, so anything within a grouping symbol will always be horizontal, and anything outside of the grouping symbol will always be vertical. Okay, and then on this one, okay, this is a quadratic, so it's going to be a U shape. Our parent quadratic generally looks like this. So this minus 3, which is outside the grouping symbol, is saying that I'm going to take all this quadratic stuff and scoot it down by 3. So you should get a quadratic that looks roughly like that. Hopefully you can draw it a little bit better than I can on my tablet. Alright, now vertical stretch or compression. So remember, we're looking at the A value. Looking at the A value that's right here in front of the x squared. So here, this 3 is bigger than 1. So this means that we are going to have a vertical stretch. On this one on the right, because it's a fraction, like 1/2, that's going to be a vertical compression. So the way that we do this is we take these values and we multiply them by the values of our anchor point. So we're looking at the y value of the anchor point here because it's vertical. So with this 3, okay, on my quadratic, my first anchor point is at 0. So 3 times 0 is 0, so it starts here. Now my second anchor point, these ones have a y value of 1. So 1 times 3 is 3, so my second anchor point scoots up to here to 3. And then I'd go to this one, okay, the next anchor points are at 4. If I times that by 3, that would be 12. So this parabola is going to stretch like this. It's a really, really, really long stretch. Now for the vertical compression, again, you're just going to take that 1/2 and you're multiplying it to each of your anchor points. So here I'm at 0. Okay, so the first anchor point's at 1. 1/2 of 1 is 1/2. So these just fall just a little bit. My next one is at 2. 1/2 of 2 is 1. Okay, next one is 3, so it will be at 1.5. So you should see that your absolute value just kind of comes like this, a little squished down, if that makes sense. Now, because of the nature of how we find the other points, you have to make sure that if you have a stretch or compression, that you do that before you do any translations. Otherwise, it will mess you up. All right, so our next one is talking about vertical reflections. So a reflection is when we flip a function upside down across the x-axis like this. And it happens when you have a negative sign being multiplied outside of the grouping symbol. So here's a cubic function. So that negative reflection that you see right there, or right there on the absolute value, will cause this to go upside down. So here I have an anchor point at +1. That'll make it go to -1. And here I have an anchor point at -1. That'll cause it to go up to +1. So this function is now going to go like this. All right, for my absolute value function, again, it's starting at 0, 0. And then we're taking these values and essentially just multiplying them by -1. So this anchor point is up at +1. Now it'll be down at a -1. And then a -2, and then a -3, etc., etc. So our absolute value function comes oops, comes down like this. So these transformations, they work on all functions. You can do this with any type of function. That's why I'm showing you with a lot of different types of examples. So let's go ahead and let's combine them all. So here we are. I have a quadratic. I know that because of the square that says that it's quadratic. Okay. This 3 is being multiplied outside the grouping symbol, so it's a vertical stretch because it's bigger than 1. This -1 is something being subtracted inside the grouping symbol. So this is going to be a translation to the right by 1. And then this -2 is outside the grouping symbol. So this is another translation, but it's going to be going down. So let's take a look at this. So I usually recommend maybe doing this in 2 parts. The first part I'm going to do in this lighter blue color. I'm going to do my stretch. So remember, the vertical stretch, you take these anchor points and you multiply their y value by 3. So here this first one is at a y value of 1. So it's going to stretch up like this to 3, because 1 times 3 is 3. The next one's at 4, so it would stretch to 12. So here I've done my vertical stretch. Then we do our translations. So I'm no longer going to be worrying about the white graph. Now I'm worrying about the brighter blue graph. So I'm going to take this brighter blue graph and I'm going to scoot all of these anchor points I have, the 3 that I have, to the right by 1 and then down by 2. So this one that's at 0, 0, right 1 and down 2 will be right down here. This one that's at 1, 3, I go right 1 and down 2. It'll put it here. Right 1. Oh, I didn't quite count 3 correctly, did I? Or I'm sorry, right 1 down 2. Sorry. There we go. And so our parabola, now that it's been transformed, is this one down here. So sometimes it's easier to do the 2 steps, and it might help you to go through the process easier than if you do it all at once. You can still do it all at once, but you have to be very comfortable with your functions. And that's that. Until next time.